Okay, time to get back at it. I want to do a little bit of a review of a couple of things here before we go any further. I want to look at our integers again for just a few minutes. I know we've been using them, but a couple of things I want to point out and a couple of terms I want to define. Something that's going to come up in the homework is something called absolute value. And I've used this term before, and I've briefly mentioned it, but I want to make sure everybody understands what it means. Absolute value means the length of the vector. That's that arrow we were talking about. So if I'm thinking of my number line, where I have 0 in the middle and I number out in both directions, positives to the right and negatives to the left, the vector for a 7 looks like that. How long is that? 7, yeah. So the symbol for absolute value is 2 bars that look like that around the number. So this is asking, what's the absolute value of 7? Well, it would be 7. What if I ask, what's the absolute value of a negative 7? Well, negative 7 would start here and go to negative 7. Starts at 0 and goes to negative 7. How long is that one? Just 7. It's 7 units long. So the absolute value takes out the direction. It's just asking for a pure length. Now, don't take that to mean it always makes it positive, because that's not true. The answer will not necessarily always be positive. This absolute value symbol is actually another form of enclosing symbol. So I can have something like this, the absolute value of 2 minus 8. Inside there, what is 2 minus 8? Negative 6. Now that I've reduced what's inside that absolute value, inside my enclosing symbol to a single number, now I can take away the enclosing symbol, just like I did with parentheses. The difference is in parentheses, I just took away the symbol. With absolute values, I actually have to do something when I take them away. I have to find the absolute value of negative 6, which is 6. So that one comes out positive. Again, easy to get stuck on that rut of saying, well, absolute value just makes everything positive. But we can have a problem like this. Here, there's 2 absolute value symbols. Just like with parentheses or anything else in our order of operations, we go left to right. So we're going to do this one first. Is there anything that needs to be done inside that absolute value symbol? No. So I'm going to do the absolute value and take away the enclosing symbol. So what do I get there? Absolute value of negative 4 is 4. Now I have to do this symbol here. Is there anything that I can do inside that one? You got it. 2 minus 9, which is negative 7. Now I've reduced what's inside that one to a single number. Again, I can perform the action to get rid of the enclosing symbol. What is the absolute value of negative 7? Positive 7, or just 7. But I still have 4 minus 7, don't I? Which is negative 3. So even though there's absolute values in that, I do not get a positive answer. So be careful with that. What comes out of the absolute values must be positive. But the answer is not always positive. Now this problem here is not as tough as it looks, because there's really nothing for us to do. Can you tell me why? What's that? Well, we've looked at solving equations to just try to solve for x. The problem is, I'm saying that the absolute value of something is equal to -8, right? What number could I take the absolute value of and get a -8? Nothing. There's absolutely nothing I can take the absolute value of. So there's no value, no matter what x is, there's absolutely no value that this could be in here that would make this true. If I use an absolute value in an equation, it must always equal a positive number. If there's a negative number, now that's only if the absolute value is by itself. But when the absolute value is isolated, it has to be positive. The absolute value cannot be a negative value. So we have to be very, very careful with that. We're not going to solve absolute value equations at this point. But as we get more into it, it's something to be careful of. And it can be hidden too. We could have something like this. That looks okay because it's positive over here, right? But the absolute value isn't alone. If you're going to add 7 to something to get a 4, this would have to be a -3, and that can't be. You can't have an absolute value that comes out to a -3. You can take the absolute value of -3, but you can't have it equal -3. Okay, I don't want to confuse you by dwelling on that. So just do a little bit of review. Make sure we're up with our integers here. Let's figure out what that's going to be. First of all, is that going to be positive or negative? Positive, because it's a negative times a negative. And so it's going to be positive, then we multiply the numbers. What's 8 times 5? 40. Very good. Positive or negative? It's going to be negative, because we have a positive divided by a negative. It's going to be negative, and what is 32 divided by 8? -4. You got it. Perfect. This one, positive or negative? It's going to be negative. Positive times a negative will be negative. 7 times 3? 21. So -21. Positive or negative? It'll be a negative, because a negative divided by a positive would be a negative. Remember, if there's one of each, it'll be negative when you're multiplying or dividing. And 42 divided by 7 is 6. -21 divided by -7. Positive or negative? Positive. Very good. 21 divided by 7 is 3. So +3. And how about -4 times, or -8 times 4? Positive or negative? Positive, or negative, sorry. Negative times a positive is a negative. So negative, and 8 times 4 is 32. Okay, so that's multiplying and dividing. Remember, if you have one of each when you're multiplying or dividing, the answer is negative. If they're both positive or both negative, the answer is positive. It's adding and subtracting that's more difficult. When we're adding or subtracting, it's actually that absolute value that matters if we have one of each. We're looking at that picture, and started at 0. 8 goes this way. -3, does that go the same way or the opposite? Opposite, longer or shorter? Shorter. So it looks like that. So that tells us our answer is positive or negative? Positive. And the arrows go the opposite directions. So the difference between 8 and 3 would be 5. So we have negative 12 plus 9. From 0, what way do we go for negative 12? To the left, the negative direction. Positive 9 goes the opposite direction, longer or shorter? Shorter. So that tells us our answer is going to be positive or negative? Negative, and the difference between them is 3. So when I say the difference between them, I'm talking about the difference between their absolute values. This is an absolute value of 12, and this is an absolute value of 9. The difference between their absolute values, or the difference between their lengths, is 3. So negative 3 is the result. So negative 7 plus negative 8. Here's negative 7, negative 8. Same or opposite? Same. So I know my answer has to be negative, and since they both go in the same direction, I'm just adding their absolute values, or adding their lengths. 7 plus 8 is 15. It's the subtraction that got tricky. Negative 5 minus 9. Remember, we rewrote that to be negative 5 plus a negative 9. Good. We took this here, we took what we're subtracting, and we add the opposite. So instead of subtracting a positive 9, we add a negative 9. So now the picture is negative 5, negative 9 goes the same direction, so this is going to be negative, and they're the same direction, so we combine, add the absolute values to get 14. So negative 14 is correct. So 7 minus negative 10, this is really where the difficulties came in. That's going to be written as 7 plus a positive 10. So the subtraction gets changed to addition, and the sign of the number gets changed to its opposite. So this is plus a positive 10. So 7 plus 10, of course, is just 17. Negative 8 minus a negative 5. Is this going to become a positive 8? Say no. No. The first number doesn't change. It's always the number that's being subtracted. So instead of minus a negative 5, it becomes plus a positive 5, or plus 5. The subtraction becomes addition, and the number that's being subtracted becomes the opposite. So negative 8 plus 5, that answer is going to be at what? Negative 3. We'll go over that again more as we hit them again, but that said, that subtraction is really the one that stumps people. You can use your calculators, your notes, and your books on all your tests.
So being that my calculator can figure that out without having to worry about what's positive and negative?
Yep. Yep.
Okay.
This next one, though, is going to maybe stump your calculator. Try to enter this in your calculator. You guys remember where the squared key is? Most of your calculators actually have one similar to mine here, which just says x squared. So if you type that in, do negative 5 and x squared, you get 25. That should be fine. But if you're going to use a power other than 2, other than squared, you have to use a key that looks like this. Mine's over here, but most of you would be over on this left side. It's called the Caret Key. See the one that's lit up in red there? It looks like this. We talked about it a little bit the other day. If I use that key, if I enter -5 caret 2 to take it to the power of 2, enter it and see what you get. Down here, you've got that negative key. Should be down by your equal sign. So you type the negative and then you put in the 5. Yeah, if you use the minus key, it won't do it. It'll give you an error. Did anybody get a -25 for their answer? Okay. Why does some of them give you a -25? Well, I wrote it this way. Oops, go ahead.
If you're timesing it by second, it's times 5 times 5. So then you have 2 negatives and that makes positive. But if it's an odd number, you have 2 negatives and 1 positive.
Okay.
Or it's going to be a negative.
That's exactly right. And one of the things you have to be careful of in your calculator is if you enter it like this, -5 squared, I put the parentheses in up here on purpose. Because if you don't put those parentheses in, order of operations says an exponent comes before the negative. Bless you. So it's going to square the 5 and put the negative in front of it. This does not equal -25, though. You don't want that. You want anything, a negative times a negative has to be a positive. There is no number out there that you can square and get a negative answer. You square something, it should always be positive. So when you put in a negative number in your calculator that you're going to use a power with, you must use those parentheses keys. Even on my calculator here, if I did -5 x squared, it gives me -25. I have to do parentheses -5, close the parentheses, and then square it. That's telling my calculator that the negative is part of the 5, that it's a -5 and not -5 squared. So be very careful with that when you're putting in negatives to use powers with them. We're going to look more at integers with powers later. We're going to start actually in the next unit, we'll look at roots and stuff like that with our integers. But what I want to do for now that we know how to solve some of our more complex equations, I want to look at some more complex problems, word problems, for solving equations. Keeping with our formulas, one of our formulas is profit equals total sales minus total cost. Or you might put in revenue instead of sales. You know, we're referring to the dollar sales there. If an item costs $4 and sells for $10, how many do you need to sell to make a profit of $144? So our formula, profit equals, I'm not going to rewrite it, total sales minus total cost. Do I know numbers for any of those? Do I know the number for profit? Yeah, I want my profit to be 144. Equals, do I know my total sales? Well, I don't have a specific number for it, but I can write one of these algebraic expressions for it. Total sales is the dollar amount per sale times the number of items sold. What's the dollar amount per sale? Careful. $10 per sale. I'm trying to find out how many are sold, right? So I'll make that $10 times X. That's the total dollars I brought in sales. Now I'm going to subtract my total cost. I know the cost per item is $4 times the number of items bought, right? Well, the number of items I purchased has to equal the number I sold, right? We're only worried about the cost of the items we sold. So 4 times x is our cost. What do we do from here? Yeah, 10x minus 4x is 6x. And then divide by 6. So 24 equals x. If we sell 24 items, we'll make a $144 profit. So let's say the length of a rectangle is 5 more than the width. The perimeter is 74. Find the length and the width. Let's draw a rectangle. And I'm going to write out my formula. Perimeter is equal to 2L plus 2W. I know my length and my width. What do I do from here? Well, L is equal to width plus 5. W plus 5. So what am I going to do over here? Well, I'm going to replace the L with W plus 5. So instead of 2 times L, it'll be 2 times W plus 5. I can also replace P with 74. This also gives us a little bit of a foreshadow into our next step in solving equations. We simplified this type of expression earlier. We see the parentheses. There's nothing we can do in the parentheses. So we're going to multiply by the 2. 2 times W is 2W. 2 times 5 is 10. And we got the other 2W. And then two W and 2W makes 4W. So plus 10. And then, careful, subtract 10. So the 10 over here is gone. We just have the 4W. 74 minus 10 is 64. And then divide by 4. That's gone. We have W. 64 divided by 4 is 16. W equals 16. We all done? No. It's a tendency to, we wrote the equation, we solved the equation, we're all done. But we're not. We have to go back and make sure we answer the question. The question asked, find the length and the width. We just found the width. The width equals 16. What's the length? Well, it's W plus 5. So 16 plus 5, which is 21. So the width is 16 and the length is 21. How are we feeling? Ready to end the day? Okay, that's kind of where I was going with that too. That is probably enough for today. Remember, you do have a quiz, quiz 2, which is due tonight at 11:59 p.m. If you want to go back and redo quiz 1, or if you didn't get time to finish because the time zone was wrong, that will be open. I believe I set it to the end of the day Saturday. So Saturday at 11:59 p.m. There's a new homework. Homework 3, which will be due Monday at noon. If there are any of the other homeworks, homework 1 or 2, that you want to go back and work on and finish up, feel free to work on those. It might warn you about a grade penalty, but I'll ignore that at this point. We've had enough technical difficulties that I'm not going to hold you to a strict deadline so far. Anybody have any questions? Okay, so the network will stay up until noon, so we have the computer labs if you want to work and ask questions. Otherwise, have a great weekend. I'd recommend you maybe start looking things over to prep for Tuesday. We'll do a little bit of review at the end of class Monday, but this one comes up fast.